Welcome everybody to join us. Today, Dr. Janine Schweppe and myself would like to present you our brand new product, the One Shade. Thank you, Janine, for supporting me for this presentation. One fits all. Does the single shade composite meet your expectations? My name is Andreas Utterodt. I'm engaged in the development of composite materials at Kulzer and would like to explain the material science behind the product. I will start with a short introduction of the company, and we will have a deeper insight in performance and aesthetics based on material design. Afterwards, Dr. Janine Schweppe will provide study results and show the color match in real applications and the integration into the shade system. A short video will introduce Kulzer. The dental company was founded in 1935 in Germany and thus provide quality materials and solutions for oral health worldwide. More than 1,400 passionate employees take care to support dentists and dental technicians. Since 2013, Kulzer is a member of the Mitsui Chemicals Group with headquarters in Japan and more than 18,000 employees worldwide. The dental expertise of Kulzer is based on a long history, providing innovations for indirect dental treatment covering alloys, ceramics, prostheses, artificial teeth, impression materials, and more, and various polymer-based materials for direct restoration like bondings and composite products. Let's start to learn more about the TCD urethane-based composites. Dental composites are reinforced polymer-based materials with a monomer blend and special filler particles as the main components. A silane coupling agent is required to combine the building blocks by a polymerization reaction to create a strong restorative material. Moreover, some important additives are necessary for the light-curing properties to adjust the handling behavior and to achieve a tooth-like appearance. The filler particles are the main component by mass and most important for wear resistance. A narrow particle size distribution of various mean particle sizes was used for decades, and composites were classified according to the filler type and resulting properties. With the hybrid composites, the advantage of an increased packing density was understood to reduce shrinkage and improve material performance. The main content of the composite, 70 to 80%, are filler particles with a special particle size combination in the micrometer range down to some nanometers, packed and embedded in the polymer matrix. Mathematics can explain why the packing density of equal spheres are limited. A combination of different sizes and suitable ratios can achieve a much higher packing density. Such a combination may be calculated by modeling or estimated empirically. The reactive main component is a crosslinker blend. BIS-GMA is still the most common dental crosslinker since the original discovery by Dr. Bone in the 60s. At Kulzer, we have developed a new class of dental composites based on TCD urethane, with optimized properties for dental composites and free of BPA components. The performance benefits are based on a tailor-made design of the molecular structure. Tricyclodecane is a red-marked rigid core structure essential to achieve the low shrinkage. What does it mean? In the liquid stage, the rigid molecular structure needs less space. The higher density is beneficial to limit the polymerization shrinkage. and especially the non-rigid TGDMA in conventional systems, has a lower density and creates much higher volumetric shrinkage. The side chains, blue marked, are optimized for a balanced elasticity and reduce polymerization stress. The urethane acrylate groups are the reactive parts well known in polymer chemistry for high reactivity to achieve excellent double bond conversion, high strength, and fracture toughness. All optimized ingredients in combination provides an outstanding performance. The TCD urethane for excellent strength, fracture resistance, biocompatibility, and low shrinkage. A dendritic crosslinker additive providing unique handling properties and low polymerization stress. The high filler load for a permanent wear resistance and the nanofillers as part of the inorganic filler system to achieve a natural appearance and ambient shade adaptation. Now let's understand the optical properties better. Spectral translucency of inorganic-organic hybrid materials is a key feature and the result of all components. Polymers have a lower optical density in relation to any inorganic material typically. The refractive index of dental glasses is depending on the X-ray opacity level caused by heavy elements incorporated. The barium-containing glass is preferred because of a high radio opacity for diagnostics with a refractive index of approximately 1.53, similar to the silicon nanoparticles. Furthermore, we have some pigments with higher optical density. They are used to adjust the shade and the opacity level. Polymers with a low optical density require a combination with low refractive index fillers to achieve translucency. Unfortunately, dental fillers have a much higher refractive index, and there's a problem. They require a suitable polymer to avoid light scattering and opaque appearance. Only a well-balanced system of perfect matching optical densities of matrix polymer and all particles incorporated can provide a suitable translucency. And that's the key. The embedded nanoparticles are smaller or closer to the range of the wavelengths of light. Depending on the interaction of material and light, we can observe a color-depending light scattering, known as opalescence effect. Orange light can pass, while blue light is scattered close to the surface, and color may be observed depending on the relative position of observer and light. The one-shade effect is based on all these optical properties to achieve a great shade adaptation. Every color is included in the daylight, and a shade can be created by interaction with materials just by attenuation of specific wavelength areas. The resulting mixture of wavelengths is recognized in our eye as a specific color. Dental composites are great materials to design such photonic properties, as hybrid materials contain lots of small particles. The left picture shows a preferred light scattering to create a milky opalescent appearance similar to the natural enamel. A longer wavelength is able to penetrate the material much deeper, and the amber shade is transmitted to the depth. On the right side, the material is demonstrated in contact with a colored material. Now, the reflected light and color from the cavity interface is transmitted into the translucent material, and the infiltrated light is distributed and scattered within the one-shade restoration, and the appearance adapts. This animation shows the adaptation of the appearance due to the background reflection, light scattering, and blending inside the translucent hybrid material. The universal one-shade is characterized by an intrinsic hue matching the amber color space of teeth. Thin layers are very translucent, and light scattering is increasing with the layer thickness to cover the background while incorporating the adjacent tooth shade. The shade adaptation effect can be demonstrated with one-shade samples, in this case 1, 2, or 3 mm thickness, placed on top of a tooth-shaded background. Basically, this biomimetic approach is using the color from the background covered by a translucent layer. The most relevant simulation was made with tooth models prepared with a central cavity, filled, light cured, and polished. And this can be made with very different shades to simulate the excellent color adaptation potential. Discover the universal one shade and convince yourself of the advantageous TCD urethane composites, Venus diamond or Venus pearl. One shade can cover your demands for posterior restorations.
A warm welcome to this session also from my side. So my name is Janine Schweppe. I'm a dentist and I'm responsible in Kulzer for global scientific and clinical affairs for adhesive restorations. So my research and development colleague, Andreas Utterodt, has provided some background information on the TCD monomer and on the one effect already. So let's check if the one shade really keeps its promises in vivo studies, but also in the clinical reality. This slide compares Venus diamond and Venus pearl with other composites. Both materials possess very good mechanical properties, such as a flexural strength, which is very high, to reduce the restoration, fracture, or chipping. A low shrinkage stress rate to minimize the risk of marginal gaps, tooth hairline cracks, and postoperative sensitivity. Additionally, both materials are not so sensitive towards ambient light to allow the dentist a stressless reconstruction of proper functional surfaces. And to keep these functional surfaces stable over a long time, both materials also show a very low abrasion rate. Last but not least, the materials ease carriers diagnostics by a very high radiopacity level. And apart from its optical appearance, the one shade has the same physical properties than the other shades of the Venus diamond and Venus pearl system. So the studies done on Venus diamond and pearl apply also to the one shade. Fracture and secondary carriers are the main reasons for restoration failure. And this was the reason why we have focused during the development of Venus diamond and Venus pearl on a high flexural strength and a low shrinkage stress. What you can see here in this graph. So we have here those triangles representing the flexural strength, and we have those bars representing the shrinkage stress. Both composites exhibit, therefore, the unique combination of a very high flexural strength and a very low shrinkage stress. Various studies have been done already on both composites. In the following, I will focus only on some of them. This slide shows the flexural strength values after 24 hours in water, represented by the left bars, and after 10,000 thermocycles, represented by the bars on the right-hand side. And this study was done by Professor Illy from the University of Munich. So we can see that aging leads to a certain drop in flexural strength, but in Venus diamond and in Venus pearl remains it on a very high level. And the difference of the flexural strength after aging between the Venus composites and omnichroma was statistically significant. This study done by Professor Ernst from the University of Mainz depicts the low shrinkage stress Venus diamond and Venus pearl possess. So you may asking yourself, okay, I have seen now some results of laboratory tests. But how do both Venus composites behave in the clinical reality? So we did 10 clinical trials on both composites over the last decade. And here you can see where these studies took place. So 2 of the studies are still running. The blue studies evaluated venous diamond, whereas the red studies investigated venous pearl. Here's one example of the clinical study done at the University of Munich in Germany. So after 18 months, 98% of venous diamond restorations and 97% of the control restorations were assessed as clinically excellent or acceptable with predominating alpha scores. That means clinically excellent. 1 restoration of each material had to be replaced until 18 months. Most of the clinical studies are lacking long-term data because they mostly run 2 to 4 years only. But it's the question, how long can restorations based on the TCD monomer last? Of course, this is just only a single case done by Professor Ernst, and many variables affect the longevity of a restoration. In this case, an insufficient gold inlay was replaced by venous diamond in an area with high masticatory load. Due to the cavity depth, the marginal ridge of the restoration was not supported by tooth structure. In these cases, we often see clinically fractures of the marginal ridge with composite restorations in general. Here we can see the situation at a later recall. The restoration, very well visible on the radiograph, is still functionally, biologically, and aesthetically in a perfect state. And this recall photograph took place after 11 years. Now I'd like to explain how the new one shade fits into the shade system of venous diamond and venous pearl. Venous diamond and venous pearl have a broad shade range classified in 3 different levels of opacity. So the dentist can choose if he wants to do a multi-shade layered approach for high aesthetic demands, which requires, of course, a shade selection. Or if he uses the one shade approach without shade selection for the basic aesthetically non-complex posterior restorations. So one is not intended for aesthetic anterior restorations. In cavities completely surrounded by the remaining natural tooth, the shade of the one restoration is determined mainly by the surrounding tooth shade. In larger cavities and larger restorations, we also can see this effect in areas surrounded by the tooth, whereas in those areas lacking the tooth embrace, the one shade is mainly coming from its intrinsic color. This scheme displays the recommended use of the one shade. So optimum results with one are achieved in posterior restorations which are not located in the visible aesthetic zone. If there is a small buccal extension, like you can see here or there, of these restorations, but not prominently located in the visible aesthetic zone, one can mostly be used as well. But in all other locations with higher aesthetic demands, we recommend to use all for the details, and that means the usage of the universal shades or even a multi-shade approach with the full shade range of venous diamond and venous pearl. The question is if it is really possible to obtain good color matching with using only one shade. Does it really keep its promises also in the clinical situation? I will show you in the following some studies and clinical cases. This was an internal study with 5 dentists here from Kulzer, and those dentists were blinded, so they did not know which material they had to evaluate. They had to rate the color match according to the FDI color match criterion. Tested were 3 composites in occlusal class 1 cavities in denture teeth made of 3 different shades, B1, A2, C4. And you can see here the mean color match values for the different composites. All 3 tested composites received at least a clinically satisfactory rating. So no significant statistical differences between the materials were detected. And how does one performs in the clinical reality? Here you can see different restorations of venous diamond and venous pearl 1 done by different dentists worldwide. All restorations show a good color match to the surrounding tooth structure. So it's very easy for everyone to obtain good and reliable results using the one shade for basic posterior restorations. The one shade works in smaller and even in bigger cavities. Because of its good physical properties, it was also used for a direct partial crown, as you can see here on the left-hand side. So we have reached the end of our presentation now. Coming back to the title of this session, One Fits All. Does a single shade composite really keeps its promises? We agree, because it's a truly universal shade for most of the everyday posterior cases. It saves time as no shade selection is needed. It fits and complements the Venus Diamond and Venus Pearl shade system. And last but not least, its TCD formula is the ideal prerequisite for long-lasting restorations. So, we like to thank you for your kind attention. And if you need any further information, please contact your local Kulzer sales representative or visit our website at kulzer.com/Venus.